Hello everyone, myself Prayak Patel, working as Assistant Professor in IT/ICT Department of LG Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the next concept of graph theory. It is called the generalization of the principles. We already discussed the inclusion and exclusion principle in our previous video lecture. Now we understand what is the general form of that. What is the generalization of the principles? So here, consider a set S with mode S equal to n. That means element in a S equal to n. And conditions C1, C2, C3 up to Ct satisfied by some of the element of S. So C1, C2, C3 up to Ct considered as a different conditions for that. Now, here we already know the principle of inclusion and exclusion. So we saw that how the principle of inclusion and exclusion provide a way to determine n C1 days, C2 days, C3 days up to the Ct days. That means number of elements in S that satisfy none of the T conditions. So C1, C2 up to Ct, no any condition will satisfy is called the n C1 days, C2 days, C3 days up to the Ct days. Now, this is called the principle of inclusion and exclusion. Now here, new concept is like if M belongs to Z plus and 1 less or equal to M less or equal to T, we now want to determine EM. Now what is the meaning of EM? EM means exactly M of the T conditions. That means which denote the number of element in S that satisfy exactly M of the T conditions. So total T condition are available C1, C2, C3 up to Ct, and you want to exactly satisfying M conditions. So for example, M equal to 1, then only one condition is satisfied, exactly one condition satisfied. If M equal to 2, then exactly 2 condition is satisfied. If M equal to 3, then exactly 3 condition will satisfy. So it is called the E of M. Now for this equation, we consider the first equation as a E of 1. That means exactly one condition will satisfy is called the E1. So common equation for the E1 is equal to n C1, C2 days, C3 days up to Ct days. Only C1 is without days. Remaining all are considered as a complement. Plus second term n C1 days, C2, C3 days up to Ct days. Up to the last term plus n C1 days, C2 days, C3 days up to the Ct minus 1 days, and last term is a Ct. That means in first term only C1 is satisfied, exactly C1. In second term exactly C2. In third term exactly C3. Up to the last term exactly Ct. So addition of this all consider as a exactly M of the T conditions will satisfy. Now same way we can write the equation for E2. E2 that means M equal to 2. So exactly 2 conditions out of the T condition will satisfy. So exactly 2 condition means, for example, n C1 C2, then 1 3 C1 C3, then C1 C4, like this. So common equation is n C1 C2 C3 days C4 days up to Ct days plus n C1 C2 days C3 C4 days up to the Ct days up to the last term plus n C1 days C2 days C3 days up to the Ct minus 2 days into Ct minus 1 Ct. So this is a common form for the E1 and E2. E1 means exactly one condition will satisfy. E2 means exactly 2 condition will satisfy C1 and C2, C1 and C3 like this. Now in this way we can consider the one example. Here in this figure we consider the 3 set and combination of these 3 sets C1, C2 and C3 are available. That means the C1, C2 and C3, these 3 consider as a conditions. So T equal to 3. Total number of condition is considered as a T. So T equal to 3. For this following figure, where T equal to 3, we place a numbered condition based on this circle representing those element of S satisfying that the particular conditions, and we also number each of the individual regions in this figure. So here in particular region, in particular figure, we write some number, and this number represent the number of element, or that number satisfy the conditions. So for example, one right in outer place, that means C1, C2 and C3, outer side of the C1, C2, C3 region is called the region 1. So simply we can say that the number is representing the region number, not anything else. So 1 is a outer region, 2 is considered as a only C1, 3 is only C2, 4 is only C3, like this. So here when we find the E1, that means only one condition is satisfied. So only C1 is satisfied, or only C2 is satisfied, or only C3 is satisfied, then we consider the result of this is considered as a only one condition is satisfied. So for that, then E1 equals the number of element in a region 2, 3 and 4. So see in this figure, region 2 is only C1, region 3 is only C2 and region 4 is only C3. So combination of these three region 2, 3 and 4 is considered as a only one condition E1 is satisfied. Now we have already equation for the E1 is available. Now see the another equation, another formula for the finding the E1 for these three sets C1, C2 and C3. So E1 equal to NC1 plus NC2 plus NC3. That means individual condition C1, C2 and C3 minus combination of two elements. So here minus 2 times N C1C2 plus N C1C3 plus N C2C3 plus next condition is a 3 N C1C2C3, means 3 times 3 conditions C1, C2 and C3 satisfied. So this is called the common equation for finding the E1. So for that, here understand what is the scenario in this equation. So in this equation we see that first 3 term as a NC1 plus NC2 plus NC3. So in this 3 term we consider the element of NC1, element of C2 and element of C3. So here we write the formula and use the equation, then we can find the result as a 2, 5, 8, 6, 3, 5, 8, 7, 4, 6, 7, 8, because we count the each and every element. So C1 containing the element like 2, 5, 6, 8. C2 containing the element 3, 5, 8, 7. C3 containing the element 4, 6, 7, 8. Okay. Then here we can say that in this region 5, 6 and 7 used twice and 8 used 3 times. So see in this scenario 5 repeated 2 times, 6 repeated 2 times, 7 repeated 2 times and 8 repeated 3 times. Now in second term 2 NC1C2 plus NC1C3 plus NC2C3. In this term, how many times particular element is repeated? So for that, here we write the minus sign and we use the minus 2 in front of NC1C2, NC1C3, NC2C3. That means we have to write the 2 times every term. Now NC1C2, that means common element of the C1C2. So common is 5 and 8. So minus 5 write 2 times, minus 8 write 2 times. Now next is C1, C3. That means common of the 1 and 3 is 6 and 8. According to this figure, common element of C1 and C3 equal to 6 and 8. So minus 6 2 times, minus 8 2 times. Then third portion is considered as a C2, C3. So in C2, C3 common element is 7 and 8. So write the minus 7 2 times and minus 8 2 times. So minus 7 minus 8 like this. Now after that, last term is a 3 NC1 C2 C3. Now NC1 C2 C3, that means common element of C1 C2 and C3 is called the 8. So we write here 8 3 times because 3 into NC1 C2 C3. So 8 8 and 8. When we simplify this equation, when we simplify this 3 portion, then we will get the exact value. Only one condition is satisfied. Then result is called the 2, 3 and 4, because only these 3 elements are remaining. After subtracting this, all the element addition or subtraction operation we can perform and we will get the result as a only 2, 3 and 4 element, and it is called the only one condition is satisfied. So only C1 or only C2 or only C3. Now here see this example. In this example we can say that the common equation of E1 is like first equation. Now first equation can be represented in another way, is like E1 equal to S1 minus 2S2 plus 3S3. So S1 equal to all the combination of individual element means N1, NC1, NC2, NC3. S2 means N1, 1, 2, 1, 3, 2, 3 means NC1, C2, N C1, C3, and C2, C3. And S3 means all the three elements C1, C2, and C3. Also we can write this equation E1 is like E1 equal to S1 minus 2C1 S2. 2C1 answer equal to 2 plus 3C2 S3. And according to this we can find the result as a only element 2, 3 and 4 according to this figure. Now see here. In this example we also find the E2. That E2 means we have to find the exactly two condition will satisfy. So when we turn to E2, our earlier formula indicates that we want to count the elements of S in a region 5, 6 and 7. So here we can say that the common element, exactly two condition will satisfy. That means C1 and C2 common element is 5 and 8, but 8 common for all the three. But only 5 is common for C1 and C2. So 5 common for C1 and C2. Then 6 common for region 6 common for C1, C3 and region 7 common for C2, C3. So we want to find the E2 means we want to find the answer as a 5, 6 and 7. Now formula for the E2 equal to N C1, C2 plus N C1, C3 plus N C2, C3 minus 3 times N C1, C2, C3. Because here we consider the two element as a first portion and 3 element as a second portion. So common formula is E2 equal to S2 minus 3S3, and also we can write the S2 minus 3C1 S3, meaning of the 3C1 equal to 3. So here we write the 3S3. Now here this is a common equation. Now use the some another concept in this figure. In previous figure we only consider the three conditions C1, C2 and C3. Now we add the one new condition as a condition C4, and some element are represented, some region are represented according to C4 condition. So here we represent the region for the C4 as a 4, region 8, region 9, 11, 12, 13, 14 and 16. So this region included in C4. Now for that we have to calculate the E1, E2, E3 up to EI. So here I value is 1 less or equal to I less or equal to 4. That means E1, E2, E3 and E4. Now first we find the E1. E1 means only one condition will satisfy, and only one condition satisfy, then what is the region number? So here region number is 2, 3, 4 and 5. This region is considered as a only one condition will satisfy. So equation for the E1 is equal to NC1 plus NC2 plus NC3 plus NC4, all the individual condition, minus 2 combination of two element means NC1 C2, C1 C3, C1 C4, C2 C3, C2 C4, C3 C4 plus combination of three element. So plus 3 N C1 C2 C3, C1 C2 C4, C1 C3 C4 and C2 C3 C4 minus 4 and all the conditions C1 C2 C3 C4. So this is a common equation. Now according to S1, S2, S3 we can write the E1 equal to S1 minus 2S2 plus 3S3 minus 4S4, and also we write the in form of NCR. So S1 minus 2C1 S2 plus 3C2 S3 minus 4C3 S4. So we consider the equation is like this, and in this formula we can consider the E1 equal to value 2, 3, 4, 5. Now according to this we can find the value of E2 also. So common equation for the E2 equal to S2 minus 3S3 plus 6S4. So here another way of this formula is E2 equal to S2 minus 3C1 S3 plus 4C2 S4. So we find the value for E2. E2 that means only two conditions, exactly two conditions will satisfy. So here according to this figure we can say that the exactly two element or exactly two condition will satisfy is considered as a first 6, between C2 C3, then 7 between C2 C1, then 8 between, here we use the 8 between the C2 and C4, then 9, then 10, then 11. So this all the elements are satisfying exactly two conditions. Now here representation of S2, S3 and S4 is like this. S2, that means here we can consider this C1, C2, C1, C3, C1, C4, C2, C3, C2, C4 and C3, C4. And all the values of this C1, C2, C1, C3 like this. So this is a resultant value for S2, S3 and S4. So n C1, C2 equal to 7, 13, 15, 16, then 10, 14, 15, 16 like this. So see all these value for the S2. Now S3, that means three conditions. So C1, C2, C3 equal to 15, 16, C1, C2, C4 equal to 13, 16, then 14, 16, then 12, 16. And last S4 means all the four conditions. So region is equal to 16. So these all are the considered as a region. So 16 satisfy all the conditions C1, C2, C3 and C4. Now for that, next find the value of E3. Exactly three conditions will satisfy. And equation is S3 minus 4 S4. So another way of this formula is S3 minus 4C1 S4. And here region that satisfy the exactly three conditions satisfy. That means satisfy the condition C1, C2, C3 or C1, C2, C4 like this. So how many region are possible for that? So region is region number 12, 13, 14 and 15. These four regions satisfy exactly three conditions. Now next is exactly four conditions. That means all the four conditions satisfy. So exactly four condition means E4. So E4 equal to S4 and result of this E4 equal to 16 because region 16 satisfying all the four conditions. So this is a simple way of representing how we can find the E1, E2, E3 up to Et. Now theorem according to this formula is theorem for exactly element. So here for each 1 less than m less or equal to t, the number of element in S that satisfy the exactly m of the conditions C1, C2 up to Ct is given by this formula E of m. So here C1, C2 up to C3 or Ct is considered the different conditions, and we have to find the exactly m condition will satisfy out of this t condition. So always m is less or equal to t. Now first E of m equal S of m minus m plus 1 C1 S of m plus 1 plus m plus 2 C2 S of m plus 2 minus up to the minus 1 raised to t minus m t c t minus m st. So this is a common formula for finding the exactly m condition out of the t conditions. Now another theorem is theorem for at least. So at least m condition will satisfy. In previous case we considered the exactly m condition will satisfy. Here we write the at least m condition will satisfy from the available t conditions. So if Lm denotes the number of elements of S that satisfy at least m of the t conditions, then we write the common formula for the at least m condition is L of m. In exactly we write the E of m, in at least we write the L of m. Now L of m equal to S of m minus mc m minus 1 into S m plus 1 plus m plus 1 c m minus 1 into S m plus 2 minus up to the minus 1 raised to t minus m t minus 1 c m minus 1 st. So this is a common formula for find the at least m condition from the available t conditions. Now according to these two formulas we can find or consider the one example. See here, we shall find the number of systems of two ways roads so that exactly E and at least L, two of the villages remain isolated. So here you have to find the exactly two node is isolated, or second condition is you have to find the at least two node is isolated. So here A, B, C, D and E, this 5 node is considered as a 5 villages. Now you have to consider the exactly two villages are isolated. That means A and B are isolated, then remaining all are connected. Then exactly A and D are isolated, then remaining all are as it is. Then exactly C and E are isolated, then remaining A, B and all remaining are connected. So this type of condition is considered as a exactly E condition, or exactly two villages are isolated. And another way is at least two villages are isolated. So what is the result for that? So using this formula we can find the result of this example. So first is EM, means exactly M condition will satisfy. Now what is the value of M? In our case we consider M equal to 2, because here we can find the two of the villages remain isolated. So M equal to 2 because we have to find the two villages as a isolated. So M equal to 2. Now put the value of M equal to 2 in this equation, E of M. So E2 equal to S2 minus M plus 1, means 2 plus 1 equal to 3, C1 S3 plus 4C2 S4 minus SC3, means 5C3 S5. So this is a common formula for E2. Now here we have to find the value of S2, S3, then 3C1 like this. Then we will get the S2 equal to 80 minus 3 S3 equal to 20 plus 6 S4 equal to 5 minus 10 value from the 5C3 and S5 equal to 1. And we will simplify this equation and we will get the 40 as an answer. That means how many combinations are possible, how many conditions are satisfied, that exactly two villages are isolated. So here 40 possibilities for exactly two villages are isolated. Now another case, LM. LM means at least M condition will satisfy. That means here M equal to 2, at least two villages are isolated. That means L of 2. So L of 2 equal to S2 minus 2C1 S3 plus 3C1 S4 minus 4C1 S5. So put the value of all the elements, then we will get the result as a 80 minus 2 into 20 plus 3 into 5 minus 4 into 1. And result is equal to 51. That means 51 conditions satisfy at least two villages are isolated. So here in this lecture we discuss about the how we can find the exactly M element from the available T condition, and also we find the at least M element, at least M condition from the available all the conditions as a T conditions. Thank you for watching this video.